Bismillahirrahmanirrahim. Welcome to today's another session, linear algebra. The particular topic is vector norm. So let's start our class first. Okay. So we all are familiar with about the vectors dot product and scalar product. Are not you? So for example, if we have two vector like C and D, so this is two vector. What will be the dot product? Okay, so should I give the title first? Okay, dot product. So the resultant vector is also like this. For example, our result vector is like this. Now assume that if the vector C is like A1, B1, C1, and B2, so how do we calculate this? Well, we can sum of the multiplied elements of two vector. What does it mean? Well, it means that we can multiply like this, a1 into a2, then sum rest of the elements. Similarly, we can multiply it and then addition with others element. Okay, so this is vector dot product. So if we want to show an example, we will basically show the math example on Google Colab using numpy as our focus on how do vector norms use in machine learning, and we are focusing linear algebra for machine learning, not the physics or other use cases. So we do not show or deep dive into the more mathematical example here. And the next topic is that scalar multiplication. So before we deep dive into the scalar multiplication, when we multiply two vector dot product, the result will become a scalar. Okay. So in the scalar, how do we do this? Well, uh, scalar, first of all, we write the formula like this. B means vector and n means any scalar value without zero. We know that zero can vanish everything. So scalar vector start from 1 to infinity or negative whatever. So for example, like we assume that scalar value is k and the vector is a1, b1 and c1. So same scalar element multiply with each of the element of vector like a1k plus b1k plus c1k. Okay, hope makes sense. Okay, last day we talk about the vector space. Now we'd like to show some others more detail again. This one is crucial for us. So we all know that what does the vector means. Vector means any coordinate for the simple thing like this is a value 2 2. Okay, this is a vector. So what does that actually means in vector space? Well, as we are talking about the mathematics, so consider this the vector space is set of numbers, obviously, as our topic is domain is specific, and if we add division or subtraction or any other like any scalar if we apply here, then the resultant vector will be in the same space. What does it mean? For example, if we multiply 2 this value, then 2 into 2, like this is 4.4. So 2 to multiply into 2 is 2 is a scalar element. So the result vector also in the same space. We can also, if negative, then the direction will change. So also in the last day, if you remember that the previous session, I told you that what does the all the possible element available in the space vector, like it can be scaling, stress, or shorter value, all are the possible vector beyond this space. Okay, so what will be the general equation for this? Okay, so such as we have a vector, two vector like u and b, and we have a scalar k, then any two vector at result is the same space that I already told you here. That for example, if I this 2 to add with, for example, this 3 3, obviously minus 3 plus 3, then the result vector, like just for simple understanding, if we draw the line here, then it's will be like this. Okay, so let's talk here more. For example, u is 2x plus 3 and our b vector is x minus 1. So this is the polynomial equation, is not it? 1 degree polynomial equation. If we add these two vector, what the will be the result? The result will be to the result vector also and 1 degree polynomial. Remember this. And definitely they are in the same space. For example, if you draw this matrix in the plane like this, and this one is like so, what will be the result vector like this? So if we consider this one is I j and this one is I, so j I, and the result vector is like I plus j. Okay, hope it makes sense. So there are some rules, like if we have three vector u, v, and w, all are vector, and we consider this a and b is the scalar scalar elements. These are not to the vector but the real number except one. So what will be we can show here in the space actually what happened, like I draw some random lines, but how can we find from this one to this line? For example, maybe we can multiply something with this, then we can convert this line into this point. So there are some rules. We all know that the basic mathematics stuff, like this, maybe someone are reading in the set theory that this is the uh, commutative of addition, is not it? The second one, what is, like you have three vectors, so u plus the result will be same. And interesting thing is that there is also a called zero vector. Zero vector defined as zero, and if we add something like u plus 0 plus u, the result will be a 0. P plus 0 will we will also get a 0. This called the zero vector. And the fourth rules one is like this: if b vector is exists, the b vector, and okay, and okay, this is the exist sign v inverse, then what will happen? B plus V inverse equal to 0. So we call this B is the additive inverse. For simple understanding, like we have B3. So how do we get 0? If we add minus 3, then we will get 0. And on the other hand, vice versa, similarities. Okay. Okay. We want to see some the scalars equation. So like above the same rules, these two are the vector, this one is the vector and this is the scalar. So if we do this, we will got the same result. And on the other hand, I like if we u vector, then what will be the same as like loop. All are familiar with this. This is the actually you can say space equation, or how do we perform better in the space. Okay, so now back on to the main topic, that is the vector norm. Okay, have you any idea about this? If you have, then this is the good. As so what does the vector looks like? This is a vector. Okay, uh, 10, 20, 30. So his name is like f. Okay, what does the norm means? Well, the norms means that uh, first of all, vector norms means the find of the vector length. Okay, so there are basically three norms exist: L1 norm, L2 norm, and last one is max norm. Don't worry or be panic. How do we calculate the norm? Let's start from the L1. So assume that our f vector. Okay, so how do you find this? Well, we all know this sign. We ignore the actually negative sign. This is called the absolute value, and we put 1, the subscript of 1, as we are finding the length of the vector. So what does the f1 means here? Okay, no, f is 1 here. It means that it if it has value, like we add this, like at as we have three values, so f1, f2, f3, then we can add this. Simple. This is the L1. Okay, so normalization in machine learning, if we have no idea, then you will hear that we have to do some normalization technique in deep learning or machine learning process to for better output get. Okay, so we'll not talk about this stuff more here. So you guess guess what? How do we define the L2 norm? Okay, so if you want to find the L2 norm, what it should be like, we know that already. This is the absolute sign, and we want to find this time is like f1. Okay, so where do I get this value? Well, in the earlier I denoted this f vector is here, so we work for this. Okay, so the result is something, this will be the our L2 norm. Okay, and it's also known as Euclidean norm. This is an great mathematician, if I am not make mistake, he comes from the Greece. Also you hear the famous from the Euclidean distance. For example, if we have 2 points like this, x1 and this y1, two random values, so how do we find the line distance? I hope though it is not related with the vector norm, but it is related that name of the scientist mathematician Euclidean. So how do you find this? I hope you all know that. We will find this way the distance of the line. Okay, I'm not sure we will have any topic about the line in the future. If we have, then we will uh, definitely go through this. Now the third one, max norm. We already saw two type of normalization vector. One is we calculate the cumulative of sum, all sum of the element value. Another one is we calculate the square uh, values, and then we find the value of square root. This is the L2 norm. And in the third, basically in here, you can say sometimes the notation like this, infinity. This is our vector f, so we can write this. Okay, infinity. And what will be goes the result? The result actually like max f vector. So in the element of this, we know that the max is 30. Okay, so you can see that three different value for three different type of normalization. So how do we use in our this in the numpy? Well, we start from our so the first good, we all know that first we must have the input numpy array, and numpy which handle the all mathematical stuff for machine learning. Okay, let's take an example like this. If we have same vector like, then if we want to dot product, actually what will be the result? 1 plus these two 4 and these 3 9, then we will find the 14. Okay, so let's see what will be the our numpy return in Python. Well, we can see this 14 is the answer. Okay, I print out these two and run this, then you will see the multiply of vector dot product. Okay, in the scalar we see that the v is a vector and s is a scalar Rashi. Then if we run this, we can see that the result of the vector. So we define c is zero point 0.5 a value. Okay, run this and we will see that this the actual value 1 to 3 change. Okay, if we run this 10.5, see the value goes to increase. Okay, so how do we find actually norm in numpy? Well, for this we have to import another library from numpy, that is you can see here this this means linear algebra. Okay, where we import the norm, then we define. So you see that here we pass additionally 1, which means that we want to find the one norm L1. That's why if we and we know that the total sum of value L norm 1 is the distance of or length of any vector, and L2. Okay, so if you have maybe question that we pass here L1, but for L2 we should be pass 2 here. Basically in the norm it is by default the L2 vector norm, so we just left as it is. So whenever we find this, the result actually like this. And for the vector max, so how do we find this? We have to pass infinity. For the first one we pass 1 L1, and for vector 2 we pass infinity, and we got the max norm. Okay, let's change the value. Actually, can it find this? Yes, the value is changed. Okay, what if I pass 2 here, will the value actually change? Okay, so if we do not change, but if we pass 1 here, it goes to change. So 2 is default value, we can pass it, otherwise not pass. So this is the way, simply way we can actually show the mathematical implementation in Python using uh, with help of numpy, math infinity, and linear algebra API. So this session all about it, and next session we'll talk about the matrix and its use case of machine learning.